Good morning, everybody. It's indeed a pleasure for me to be here to give the plenary talk at the very prestigious conference of oceans, that too in Taipei. I would just dwell upon some of the ocean observation programs in India, which we started quite long back, because India has got, as you know, a very long coastline, about 7,500 kilometers, including the islands. We have islands in the Bay of Bengal as well as in the Arabian Sea. I would just touch upon the need for the observations, the genesis, how it came across in India, and some of the ocean observation systems, especially the buoys, the drifters, the other type of observation systems. I'll also dwell upon some of the modifications and the indigenization efforts which we have done in the country. Also, we'll just go to the future programs and then some of the new technologies, and I will conclude in the next 15 to 20 minutes. So it's all well known that everywhere we talk about climate change and global warming and things like that. So how well we can define about the global warming or anything of that sort? That requires very, very accurate measurements, first of all. The land measurements are quite done very well, but unfortunately in the oceans, the observations are still very limited. And it is essential that to design any structure in the offshore or anywhere, it is highly necessary that you have to measure all the parameters in the ocean. Also, a lot of satellite observations are there nowadays, which is very, very popular, but still that requires validation with ground truthing. So all these things indicate that we really require a good ocean observation program for the oceans. This is from the NOAA, courtesy NOAA. The lot of observations are there. You can see the buoys are there, the floating platforms are there, the moored buoys, various types are there. You can see that many are there. And you can see that some of these locations are still not very well understood. So it is still necessary to have further ocean observation programs. Coming to the observation programs in the Indian seas, I will touch upon the moored buoys, the Argo floats, the tsunami buoys, the high frequency radar, and the drifter. If you see, this is the Indian Ocean Observation Network. This is a subset of what I just showed from the NOAA. Here we have the Argo floats, the Rama moorings. There are some moorings which we have in collaboration with NOAA. We have those near the equator, and we have the ADCPs, drifters. All these things are shown here, apart from the coastal observatories where we measure the tides online. The buoy technology, India, we started with the Indian Meteorological Department. They are responsible for the weather prediction in the country. Even though it was started sometime quite long back in the mid-80s with some 10 buoys, this was not fully implemented. The buoy was a good design with a lot of measurement systems, but this is something which did not take off. This was supposed to have a communication through Indian satellite INSAT with this suite of transducers. But with the implementation, or rather with the formation of the National Institute of Ocean Technology in 1993, that is the institute where I come from, we had a national data buoy program which started in 1995-96, and we had the first launching of the buoy. You can see that 15th August 1997. This is the Independence Day of India. We got independence in 1947. This day. So we launched the first data buoy program, data buoy on that day. Initially we had some assistance from NORAD. Subsequently we took over completely, and NIOT has established a good facility for this. We have a 12 buoy network. Initially this was a spar buoy, as you see here. Next we had the discus buoy. These are the drawings of that. Subsequently, we have done a lot of modifications in these, as you can see later on. But we had all the sensors which are from the international market. The atmospheric scientists and the oceanographers insist that we should have these sensors from specific agencies by virtue of their higher accuracy, etc. So we procure it from the international market, and the complete system is interfaced with the system in our institute at Chennai. You see, this is the Met Ocean Buoy, which measures all the atmospheric parameters. And after some time, it was felt by the oceanographers that it is essential to measure the subsea parameters like the subsea temperatures, the currents, the salinity, and many other features on the ocean. And hence we started another program called OmniBuoy program. We can see that this has got a suite of transducers underwater. And the tsunami which struck India in 2004, we did not even know what's the meaning of the word tsunami before that, very unfortunately, after which we have established a tsunami buoy network, which I would dwell upon shortly. So the Met Ocean Buoy has got a sensor fit like this. It measures these parameters and it transmits through a Immersat satellite to the Earth station at NIOT. Coming to the OmniBuoy, it measures many parameters. As you can see here, many of the parameters are in the atmosphere, but more importantly, it has got measurements here, subsurface temperatures, even up to a distance of about 500 meters. We have got acoustic Doppler current profiler, which can measure again the currents up to 500 meters. And this has been a very important program, which you will see shortly. I will explain about how this helped in the societal way, how it benefited India. We also have a program wherein we have similar buoys in the coastal regions, especially the Andaman. Some of you would have heard, Andaman is a very, very beautiful island. I would like you to visit the place. It's quite beautiful. A lot of coral reefs are there, wherein it is essential to measure the health of the reefs, because you know the climate change and all these things, like when you get some infection, you get a fever. So something similar, the coral health gives the health of the ocean. So we have a specially designed buoy, because a lot of environmental issues are there for mooring it. You can't moor it like the conventional buoy, so we have a special mooring for that. So we measure the parameters in the coastal region, especially in the coral regions. Now coming to the tsunami buoy, it's a conventional one. Now throughout in the region of faults, we have got these buoys. It measures the subsurface water level here. You have got a bottom pressure recorder, and it continuously measures it and acoustically transmits it to a floating buoy, which transmits the signal through satellite to our institute, wherein in case of an underwater seismic event, the water level variation would be going through a tsunami algorithm, and then finally it will indicate whether it will be a cause of tsunami or not, and appropriate warnings will be issued to the respective regions. So this is the tsunami buoy which we have. Now we have this Earth station in NIOT. How it works, it depicts here. The buoy data goes through the satellite, and we have the data logging and processing system here. This is in the buoy, and this data comes through the satellite to NIOT. This is located in NIOT, wherein the reception system gets all the data and it transmits to other sister institutes of our ministry, wherein all warnings and other dissemination of information takes place. This gives an integrated picture of all the moored buoys. It includes the Met Ocean buoys, the Omni buoys, the tsunami buoys, the reef buoys, all of them at various locations. You can see that. Let me just touch upon some of the data which we got from this. We had quite a lot of cyclones from October 2010 onwards, as you can see that. I'll just dwell upon some of them and indicate how the data which has been measured by the boys has significantly helped India. If you see here, we had a cyclone called Leher, which really passed very close through the buoys, CB, that's coastal buoy 01 and BD12. And you can see that how the air pressure varied here, came down, the air temperature came down, the wind speed increased, and the rainfall, irradiance, I mean that's how much of solar energy falls there. All these parameters were measured and it went to the models for appropriately predicting the landfall point. Similarly, we had a Helen cyclone. You can see that again CB05 and BD11 measured the parameters. You can see here. This is one of the significant achievements, you can say, the Phylline cyclone, which came, it started somewhere here, and this is a cyclone path you can see, and exactly on the cyclone path, we had the data buoys, which measured the wind speed and the air pressure. And I would like to inform here that this data was put in the models, and they could predict the exact location in time and space where the cyclone will hit. And we are all very happy that there were absolutely no deaths due to the cyclone, this Phylline cyclone, because the local authorities moved the people on time and absolutely there were no deaths. So this is one of the significant achievements of a system which has been established by our institute in India. I would also like to inform here that we had a very good mooring design here. The mooring movement is shown here, and we had a lot of factor of safety and all, and it was a proven system so that we could see that when the cyclone just passed over that, nothing happened to the buoy, because buoy itself goes means all these things could not have been possible. We also have established a high frequency radar network throughout the coast of India and also in the islands of Andamans. And these are the data which we got before the cyclone, during the cyclone, and after the cyclone. We had good data of these from this HF radar. We had the same HF radar in the coast of India where the cyclone hit, and we compared the data with wave radar buoy, and the wave radar buoy till the cyclone hit, we had very good correlation with the data. Unfortunately, the wave radar buoy went off when the cyclone hit, but the HF radar also had data, so we had very good comparison. Similarly, this is a similar one with cyclone Maheshan, which came in May 2013. You can see the salinity response and the temperature response similar to the earlier cyclones. Similarly, for the Thane cyclone, which came again, the salinity and temperature, these are the locations. You can see that we had good data from them. Similarly, Jal cyclone, the temperature, the cooling effect is there. We can see that this is also a very good data output. We have a lot of rivers coming here. You would have heard about the rivers Brahmaputra, Ganges, etc. coming into the Bay of Bengal. So something like a freshening episode, because the salinity is quite low there. So we could really get all this information. You can see that the salinity coming down and the density variation, etc. All this data we could get from the buoys. The satellite validation also could be done using these buoys. As you could see that there is a lot of correlation between the satellite data as well as from the Moore data. Coral reef buoy I explained just some time before. You can see that in the year 2011, the SST never crossed the bleaching threshold. The bleaching threshold is 30.84 degrees. It never crossed. But in the year 2012, you can see the red mark. For 6 days, it crossed that, and the coral started bleaching. So that's not a good sign. So we could really measure that and give indication for other models. Similarly, the tsunami buoys, which we have put in the fault here as well as in the fault here, one of the systems during the an earthquake which happened near Pakistan. The data was captured here. Similarly, in another earthquake in April 2013, again we have captured this data, so a lot of information is available from that. We have a very good advanced data reception software system where all this data comes and it is disseminated, and you get all the parameters can be measured of the buoys, and its own health could be also monitored, but how much is the battery life, and all these things are possible. This works on an automated mode 24/7. Now something is very, very bad also. We have acts of vandalism in the ocean, wherein these buoys which are put are damaged. Some are intentional, but some are by mistake. Fishermen do this. But this is very bad, and you see how the buoys are being damaged. So we have a race between the, so to say, the vandalizers and the technology designers like us. What we did is, we have lot of design modifications done on them. We had a specially designed tools for this purpose so that we don't get into any issue. They cannot open it. We have designed it such that it is slippery, nobody can get into it. We have put cameras there so that you can watch. Maybe we cannot go there and immediately catch somebody, but at least you can record it and later watch and find out who has done it. And we also have a lot of societal programs wherein we go and inform the fishermen as well as the fishermen in other countries, the neighboring countries, that this is a friend for them and not something to be damaged. We have certain drifter program, wherein the drifter we have put with Indian satellite communication. We have some correlation between the one which we have developed indigenously as well as the one which we have procured from international sources. You can see that how the drifter moved here is shown here, and we have some very good anomalies which we have found out here, which we are analyzing. And we had a very good comparison, as you could see, between the one buoy which was from the Marian Hugh and the one which was indigenously done at NIOT. As you can see that it can never match, because in the ocean current, even if you put anything in one location, it can just go even in a diametrically opposite direction. So we can't get it, but to some extent we could do a calibration in this form, and this was a successful one. We would be transferring this to the industry. We have a very good Argo float program, wherein we have a lot of Argo floats in the various locations which measures the parameters. We also have some of the temperature and salt profiles which we have got in using Argo floats. We also indigenized the same thing. You can see the first Argo float indigenized we have put in this location, and we have got these parameters. We plan to go ahead with future in gliders, and also India has been given an observer status in the Arctic region. So we have a good Arctic program, wherein in the region of Kongsforden we are going to put you can see that we are going to put a mooring system. We also work with NOAA on the PCO2, that is partial pressure of carbon dioxide measurement. You can see that some of our team members are working with them, and this is a new program which we have just started. So before concluding, I would just give a glimpse of the other activities of our institute. We work in ocean energy, what we just now heard about ocean currents, etc. We work in deep sea mining, remotely operable vehicles, gas hydrates, coastal environmental engineering. We do good work in the ocean acoustics, marine biotechnology, marine fuel from the algae, ocean electronics, and we have also 4 ships where we use it for research purposes. So before concluding, I would like to just really thank the organizers for giving me the opportunity, Dr. Fang Cheng Chu, Professor Guo, and all the organizers of IEEE OES and MTS for giving me an opportunity to come here before you and give a plenary talk. Thank you very much.